In the previous parts of the video, we've been looking at the Boyle's Law and Charles' Law. Now we will focus on the Avogadro's Law for this particular video. Let's focus on this image here. In this image, you will see gas molecule trapped inside of a container. This container is a movable container, meaning that it can move its volume and the size based on where the disk lands. Say you were to add more and more moles of the gas. Well, because the gas takes up space and volume, it's going to increase in volume, the whole entire container. So in another case, we can say when the number of the mole increases, the volume increases. And that goes the other way around. If the number of the mole decreases, the volume will also decreases. This means that there is a direct relationship between the number of moles and volume. So in Avogadro's law, we can come up with this particular equation. VI over Ni is equal to Vf equal to Nf. Vi representing initial volume, Ni representing initial number of moles, and F representing final number of moles, and then the V final or Vf representing final volume. This could be easily illustrated by this demonstration. Now, you see a balloon that is connected to a gas tank. Say this is a helium tank. Initially, it was all flat, but then as soon as gas is introduced to the balloon expands because more moles of the helium gas is added in. Let's do a learning check based on this equation of the Avogadro's law. Suppose we have 12.2 liter sample containing 0.50 moles of oxygen gas at a pressure of 1 atm and a temperature of 25 degrees. If some gas escaped and there were 0.33 moles of oxygen gas at the same temperature and pressure, what would be the volume of the oxygen gas? So I like to set this up by writing down the initial volume, 12.2 liters, and also the number of moles initially, 0.50 moles. Now there is a pressure initially it's 1 atm, and also initial temperature is 25 degrees Celsius. Then it says that the volume has, what is the volume? Probably diminished because the final number of the moles gas has escaped and it's now 0.33 moles of oxygen. Also, the pressure and the temperature, it says that it is constant, meaning it's the same number of pressure, which is 1 atm and 25 degrees Celsius. Because the pressure and the temperature are exactly the same, we don't need to consider them in this particular problem. Let's write down the Avogadro's law, which is Vi over Ni, Vf over Nf. We want V final. We want to look for V final. So we want this equation so that V final is by itself. I will do that by multiplying Nf both sides. If this was the case, then we can cancel out the Nf, and I am left with Nf Vi all over Ni is equal to V final. The final mole is 0.33 moles. Multiplied by initial volume is 12.2 liter, and then we have my initial moles, which is 0.50 moles. Let's calculate this out. We have 0.33 times 12.2, and then divide that by 0.50, and I get 8.052. Let's keep it at 2 sig figs, so 8.1. 8.1, and we have moles canceling out and just liters left. So my V final is 8.1 liters. And this makes sense. It was at 12.2, and since gas has escaped, the volume has diminished to 8.1, and that because there is a direct relationship between number of moles and volume. Let's do a different learning check. If 27.1 grams of argon occupies a volume of 4.21 liters, what volume will 1.29 moles of argon occupy at same temperature and pressure? So in the very beginning, you have 27.1 grams of argon. Not moles, but grams. So we can definitely convert this into moles. And I will do that by adding in molar mass, moles of argon. And we have our grams of argon, which is 39.95 grams. And then go ahead and calculate this out and come back what this might be. So we have 0.678. Now, so this is my initial mole. My N initial is 0.678 moles of argon. Go ahead and find the initial volume, which is 4.21 liters. And it's asking for what is my final volume, okay? If the number of moles has increased to 1.29 moles of argon. So our Avogadro's equation is VI all over NI is equal to VF all over NF. And I am looking for my volume. So I'm going to go ahead and I'm going to multiply both sides by NF. That will cancel out the NF, and my V final is equal to NF times VI all over NI. Plug in all the values. V and final moles. The initial is 4.21 liters all over the initial moles, 0.678 moles. And you can cancel out the moles and you're left with liters, and that's good because we're looking for a volume. Let's calculate this out. So I have 1.29 times 4.21, hit enter, and divide that by 0.678. And that gives me 8.01 liters of this. Let's see if this makes sense, okay? So there is an increase in volume, and there's almost like 2 times the increase in volume, and you see in moles, and so therefore you see that almost 2 times in increase in volume. So there's that direct relationship based on the Avogadro's law.